So let's start by gaining some intuition here for small n, right? When n is 2, we know that x plus y squared is just this standard expansion here in the middle. But we want this to equal x squared plus y squared, right? Or equivalently, we just want our middle term to be 0. Now, this is only true when x or y is 0. So that's all we really need here, right? So let's do one more here quickly. Notice that if our n is 3, we have this standard binomial expansion here. And we want that to equal x cubed plus y cubed, right? So we need our inside to be equal to 0. And we can take out 3xy to get this condition here on the bottom left. And so that implies we need x or y to be 0 like before, or x to be negative y. And so I'm going to claim that if n is even, we need x or y to be 0. And if n's odd, we need x or y to equal 0 or x to equal negative y. And so for our first claim here, we know n is even. And so we'll assume y is non-zero and then show that the only way our claim holds is when x is 0. So to do that, we'll define this f of x up here and notice that our claim holds whenever f of x is equal to 0, as our two terms will be equal to each other. So let's assume there exists some x sub 0 that makes our condition hold. And so that implies that f of x sub 0 is 0 for any y. And I also want you to notice that if x is 0, our f is also 0, right? Since we have y to the n minus y to the n. Now, since f of x is a polynomial, we know it's continuous and differentiable everywhere. So we can apply Rolle's theorem, which states that if f is continuous on a closed interval AB and differentiable on that open interval AB with f of A equaling f of B, then there exists at least one C in our open interval AB such that the derivative at C is 0. Now, if that doesn't make any sense, just hold on for a moment. We're just saying that if the function at each endpoint has the same value, then at some point in our interval, we've got a point where we stop going up or down and are perfectly flat. But remember, I just told you guys at f of 0 and f of x sub 0, we're equal to 0. And so we can use those as our A and B respectively. And then Rolle's theorem tells us that our derivative has to equal 0 for some C in the open interval from 0 to x sub 0 or x sub 0 to 0, depending on which is larger. We don't really care. Since after algebra, this bottom guy here implies that we have C to the n minus 1 equals C plus y to the n minus 1, which is obviously not true, as x to the n minus 1 is an increasing function since n minus 1 is odd because n was even. So our right hand side would be larger. And so we're done with our first claim. Now, our second claim is pretty similar to this one, and I encourage you to give it a shot. You just need to apply Rolle's theorem twice, right? Since we have 3 possible zeros, so we're just doing once for our x equals 0 and one for our x equals negative y. And yeah, I hope you enjoyed that because we're done.